Some background, my name is James Turner. I did not write that on the slide. Apparently, ACCU is my time for not putting key information on slides. I've been doing C++ since I was a teenager, so you can do some math and work out approximately how old I am. I work as a consultant at a C++ consulting shop called KDAB. That's my employers. They are very open source friendly. So I'm mostly going to be talking about, as an example here, about an open source project I contribute to. The KD in KDAB has some certain relevance here because many of my colleagues work on KDE. I don't personally, I'm not a KDE person, but if you have bug reports about Kmail or Contact or something, I know who to annoy and they'll pass on to the next person and so forth and so forth. One of the good things about working at KDAB is we very actively embrace working on open source projects in our spare time. I've been working on various open source projects for 20 plus years, and one in particular I'm going to talk about here. I've often done bits of feature work, especially around UI, user interface. I've also tended to do a lot of kind of code quality, build engineering, release engineering stuff. And that's what leads me to this kind of area of conversation. I've often been on the open source project, which is too small to be something like GNOME or KDE that has like an actual support team. I've often been the contact point for end user problems and bug reports and those kind of things. So on the receiving end of irate, frustrated, possibly even angry people because the software isn't working correctly. Let me introduce the software. The software is a thing called Flight Gear. Put your hand up if you've heard of it. Wow, tough crowd. Okay, Flight Gear is a flight simulator. Hand up if you know what that is. Hooray! Okay, good. So Flight Gear is it's not but the open source flight simulator, which has been around since the mid-90s. It is the very definition of a legacy code base. There's still bits of C++ 98 in there. There's still bits of C code. And it has all the things that brings. It's an open source project running for many years. It's had contributors come and go. It's had different refactorings and rebuilds. And for a while, we were using Boost, and then we stopped using Boost, and we were using another library. And it's just got all the kind of cruft and difficulties of an open source code base. It runs on Linux and Mac and Windows, and it used to run on old-style Unixes when those existed, like Solaris and Irix. So it's just kind of your normal, large, crusty code base that only rather than being in some corporate thing, it's on a web server. But it doesn't have lots of people actively making it do all the lovely best practice for C++ version whatever that you might hope to have. Flight simulators are a weird thing because they're almost a toolbox. Even if you go and buy Microsoft Flight Simulator, it's assuming you really you spent your £40, whatever it is on Steam these days. But that isn't really what people do. They go and they buy Flight Simulator, and then they go and spend £40 on a pack that gives them a Concorde, since we're in Bristol. Or they go and spend £100 on a pack that gives them all the airports in New York. There's 4 or maybe 5. And that's like a £100 scenery add-on. Or they go and buy a thing that just stimulates hurricanes, and that's a £25 add-on. And these are all closed-source things that come from different proprietary vendors in the ecosystem around Microsoft Flight Simulator. For Flight Gear, this is all more open source code written by enthusiastic people, which the users expect to bolt into the simulator, largely data-driven via XML and via scripting language. So we're loading user-generated content, and the users are not mostly programmers, they're mostly copy and pasters. If you want to, just the scale of ability ranges from absolute pro-grade coder down to kid with notepad open, just copying and pasting things off a forum to make the aircraft fly twice as fast because he doubled the maximum thrust of the engines to be, some value rather than another. It's that entire spectrum. And I say that includes running scripts, so therefore, we've just opened the Pandora's box of the program runs arbitrary code at runtime, but not compiled code. We also download content at runtime from servers. That adds another few axes of difficulty. And of course, this is a 3D thing, so it uses OpenGL, and that immediately opens that whole avenue of ways OpenGL can be a dumpster fire. It dates from before multi-core CPUs, so there was no threading, but of course we want to run fast. So then various people who may or may not have understood threading have added threading to the code base in different places along the way. Again, this is the therapy part of the thing. And I've then come along through bits of this and been like, could we maybe use C++ 11 or 14, and could we maybe actually use some RAI objects around the threading, and could we maybe not just, pass pointers around everywhere, and just try to improve the quality, because it was a big crashy mess. But it gets better, and that's how that goes. And again, for however it worked out, I've often been the person answering the bug report tickets or emails that come in. And this typically starts with users who, again, are not really super technical. The user base, because it's a game, Flight Simulators aren't games, but they sort of align with games. You get some very young users, you get some maybe older, retired users playing around with it, and not so many of the competent people in the middle. Or at least maybe you do, but they don't report that many bugs. So we get through the 5 stages of a user-reported failure. And you can probably start to help me with them. The first one is denial. That cannot happen. Everyone been there? I mean, again, depends on what kind of project you've worked on, but okay. The next one is anger. How the hell does that happen? Of course, that brings us neatly to bargaining. If you turn off your antivirus, does it still crash? If you upgrade your NVIDIA drivers, does it still crash? What did you update in the last week? Going through those things. And they're like, I didn't change anything, it just started crashing. Okay. Then we have depression, which is, I hate computers. Why am I spending my free time maintaining this crusty code base? I'm just going to go away and live under a waterfall. And then we have acceptance, where I somehow eventually work out what was going wrong and still hate computers, but now the fix is pushed. So what I had going into this, and what triggered this whole thing, is that the users would say things like, oh, the software's got less stable, you broke it. And again, I was often the guy doing cleanups like, let's use unique pointer run auto pointer, or let's clean up the threading. And they'd see me making a lot of commits, which didn't necessarily add a new shiny bell and whistle. Like, they were just speaking of an internal code refactoring, or changing the build system. And we get these things of, oh, you've made the software less stable. I'm like, I don't think I have. The test still pass, whatever tests we have. But without any data to point to about stability, it's very hard to say. And of course, this is all very subjective feedback. Users will always get, no user will ever tell you the software got more stable, right? They're just happy. Whereas they will immediately tell you when they perceive that it's got less stable. So getting accurate feedback there is hard. But of course, it's cross-platform, and a lot of the users are on Windows. And actually, one thing that's come out of this is I now have an idea how many are on Windows, 90-something% of them. But on macOS and Linux, some users would occasionally send a backtrace. And suddenly, this was like, oh, I can maybe actually fix this. It turns out that even Linux users who have compiled from source still aren't very good at getting you an actual backtrace or a core dump. You'd be like, oh, you're on Linux, just please run GDB and then hit BT when it crashes. Very hard to actually get meaningful data out. And again, distros packaging flight gear, because again, some of the distros actually package flight gear or have at times, again, may complicate that. But on macOS, I'm an Apple person, by the way, so I tend to be a little bit skewed here. There's this nice feature that pops up an actual box containing actual text you can copy and paste out that is a backtrace with, even some symbol names in there. And it meant that even though we only got like 1% of the reports of crashes from macOS, the likelihood of fixing them was about 50 times higher, because I actually had a chance of working out what was going on. All right, so this is pretty good. If we could get the same data from other platforms, we'd be able to fix a lot of things. That's okay. By the way, in the way that users can screw up, what some users would do is screenshot the crash report box rather than copying the text. And of course, then you can't scroll to the whole crash trace, because if there's a way for users to screw up getting you data, they will screw it up. I mean, that's one of the other recurring things here. So let's take the user out of the thing and have crash reporting. That's an understood thing. Let's do that. So I went and did that. This may be teaching people things you already know, but crash reporting libraries or tools are a thing. It's usually a library and or helper process you deploy with your application. You add in some code, usually in very near the beginning, to start up the crash reporting system. Then if a seg fault or something similar occurs, it will either in process or ideally out of process go and snapshot some memory, generate a crash file in some kind of format that might be a thing called a mini dump on Windows, or might be a core dump, or might be something else. And then you ship this with your application, and it somehow come to second, talk to things. And then what you do is you build your app in release mode with debug symbols. And that's needed for nearly all the following steps. Side note here, if you're using CMake, which is, I guess, quite likely, you just go and use rel with debinfo, which does this. There's a catch. Anyone encountered this before? Correct. So the answer was optimization. Rel with debinfo with CMake does not default the same optimization flags as release. I thought it would just use the same ones and add on the, the -G or whatever it is to enable debugging. It doesn't. Release defaults to 03. Rel with debinfo defaults to 02. We discovered this after a few months of doing this whole thing. We had a 20% slowdown in the application. I was like, So yeah, if you're using rel with debinfo, which you almost certainly will, to go through all these steps, you need to go and reset the flags back to match what you actually want for your release symbols. Assuming you've done this, you then have to go and do some build system work to extract those symbols. Actually, Windows, they're in a separate file anyway, but other platforms, there's extracting the elf.debug. On a Mac, there's the dsims, whatever. You strip the code, because obviously you don't want to have the symbols in your release thing. You won't need code signing, all that. And you can automate all of this. Great. And I did that actually quite a few years ago. And this all works, right? It fits together. It's not very difficult to do. You can probably do this in an afternoon, depending on your application, but it's not hard to do. If you do things where you fork an exec, it's a bit harder because you need to make sure the crash handler follows the child processes, but it's not especially hard to do, and there's things on the shelf that will do it. So I did that actually a few years ago, and I achieved nothing. I actually went with a thing called Crash RPT, which is very simple. It's Windows only, but I was like, well, frankly, if we get Windows, we've covered the big aspect. Mac already has its built-in thing. Linux is kind of different because the vendors do their own stuff, also the distros. So yeah, and Crash RPT will basically do a post to an endpoint you supply. So I've got a dream host, cool, pointed a directory, and it zips up the actual mini dump, which is the Windows format, with some other files you supply, like maybe a log file, whatever. And you get a directory piling up on your web server full of zips which contain the crashes. And that's it. This wasn't very hard to do. It took a few days. It's working and do the plumbing. And it turns out this gets you nothing. Now, it might get you more if you had more resources than just me in my evenings and weekends messing around with this. But what's missing from all of this, the thing that makes it work, is processing that information on some kind of back end and doing analysis on it. And that's the bit that I completely hadn't understood when I'd got to this point, is that the client side or the application side integration is not the hard bit or the interesting bit of this problem. The thing that makes it useful is some kind of aggregation backend, which doesn't have to be a web service, but in this era it probably is, which will receive those reports and then do some processing on them. The big bit of processing is called Symbolication, where you go and take your symbols and match them to the build ID and then turn your mini dump and addresses into an actual stack trace you can debug from. But there's more than that, because of course you've got symbols from other vendors in there. Let's say Microsoft, but if you're using Opengl, you've also got symbols from all the vendors, and you need to work out, obviously from the list of DLLs which is in there, which other symbols to go and find and correlate those and blah, 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 blah. And this is all supported, right? There's online debug symbol services where you can go and pull this stuff all down. But you have to go and do it and maintain it and script it. So you have to correlate the symbols you're using to the build ID, otherwise nothing works because the addresses are all different. So you've got to have some kind of database to track build IDs and git SHAs and when you loaded these symbols. You also really want to add metadata into your run, so which version of software, which version of Windows, which GPU was running, all this kind of other information you might want to add in. And then you really, really, really want to group stuff based on that information, because otherwise you're just wading through this essentially flat list of thousands of reports and you can't tell what's really worth focusing on. Especially like, is the crash happening for one user a lot, or for all your users occasionally, or for all your users a lot? And that kind of question you can't answer just from the raw data, but the minute you do any kind of analysis, you can. So this is the things that make this useful, and this is the bit that's much harder to kind of organize. And certainly, again, if you're a company, you could probably just have some person go and write an entire backend that did this, but I wasn't going to do it on my own. Yeah, this is where we get into crash context. So this is another bit that I definitely hadn't realized. So just getting the crash is quite useful, but what you really want to know is, what was the user doing? How did they get there through the application? And you might say for a flight simulator, well, they're flying, but there's things like, have they just taken off? Have they just put the undercarriage down? Have they just turned on the radio in terms of the interface? There's things like, did they just open up the configuration dialog or close the configuration dialog? Has the program started up? Has it been running for 2 hours? That kind of information of tracing the user's path through the program, not at a particularly fine level, but coarsely, is really important. And then similarly, what important configuration is set. So, again, this is a 3D rendering thing, what text resolution is enabled, what are the graphic settings, so forth. And obviously, what that is depends on your application. But again, capturing it can be really vital. And the other one is what anomalous things have already happened. Because it's quite likely, again, depends on your program, that prior to an actual crash, one or more other things have gone wrong. So this comes down into logging, right? Like if you've got warnings or errors coming out, you probably want to see them in the crash report as well. So it's not just the back trace itself, it's all this other stuff, which if you can get it, will help with the forensic work that is probably the hard work, really. Another show of hands, actually, I just thought of. Who's actually done crash reporting in their software? Okay, that's pretty good. So some practicalities. The one I happen to use for flight gear, because we tried it at KDAB, is called Sentry. This is absolutely hashtag not sponsored, but was just the one that I had and worked. There's 3 or 4 solutions in this space that basically give you the back end and whatever. Sentry has APIs for many languages, like Python, Go, more things I don't need at the moment. And interestingly, again, this kind of proves where the hard work is. For the native backend, which is what I use in C++, they wrap CrashPad and or BreakPad, which are the Google libraries. Again, the library is a bit you imagine being complicated, but that's just a thing you get from Google and ignore. It's everything else after the report occurs that actually is the work. Sentry is also nice because it gives you a command line tool to do all that build step management I was talking about. It's basically got a helper tool you put on your build machine that will extract the PDBs, upload them, check what version they correspond to the executable. So when a crash report comes in, it can do the linking together of the information very nicely. It offers self-hosting and hosted solutions, but crucially, if you're an open source project like Flight Gear, they offer you hosting for free, that was a bit of a no-brainer for me. Again, there are other ones you could run, but I didn't want to spin up a whole server myself to host a different one. Again, not sponsored, but they've been pretty nice guys. Actually, the one recommendation I can give is they work in an open source way themselves, and when I've had pull requests and bugs, like there was a glitch in their CMake files, I think they turned it around in like 2 or 3 days. So they seem to be good people, but again, they're giving me a service for free, so I probably would say that. Whatever. I know at least if you're using the AppVeyor platform, you get a bunch of this stuff as well. I played with that a little bit with some other people who are using it. And again, depending on which other platform you're using for deployment, bits of this are built in. Again, I'm not going to try and do any comparison here of different technologies. It's more important to do it than agonize over how you do it, I would say. But again, if you're commercially, I guess you could go and do an actual evaluation of different features of these providers if that was your thing. I'm not going to get into that here because it's not super relevant, I would say. So yeah, that brings us to, so that's kind of what I'm doing. And what I was expecting to find is the typical crash. So Flight Gear is full of code written by people who were learning C++, didn't really understand iterators, were kind of looking at STL examples. So it's full of misuse of pointers, misuse of iterators, or has been. So I was going to find lots of code, like on the right, that just has classic, simple C++ programming errors. Not checking dereferencing things, or checking some but not checking all of them. Like so here, maybe A is valid. We check it, but we don't check if the tower is valid because not all airports have a control tower. So I was thinking we'd have basically lots and lots of stuff like this. And that is some of the crashes. But the problem is that this kind of crash, which is kind of what you imagine when someone says, oh, there's a crash in a C program, and you go and look at some example of it. They're not very hard to track down, because this is essentially deterministic behavior. I know that technically it isn't, but normally when you actually get a crash of this, it happens the same way every time, and it happens in the same place, following the same sequence of operations. So even kind of casual users can quickly figure out, oh, if I go and click that setting, it crashes. It's a very understandable, even for the user, let alone the developer, to know what might be going on there. So when someone says, oh, I was playing with the radio's dialogue and it crashed, you can almost code read and start to zero in on the problem. And if you actually do get a crash trace, then you can more or less fix it in 3 minutes. There's nothing so difficult here. So these crashes exist. I mean, there's plenty of them. But in terms of time spent and kind of frustration and difficulty and work, they're like noise. And that brings me to the actual crashes I spend the time on. And what causes them. And one of the reasons is computers are slow. Not my computer, obviously. My computer's lovely. I've got a Mac. It's fast. It's the developer machine. But because Flight Gear is free, there's some people using it who maybe don't have like disposable income to spend thousands of pounds on Microsoft Flight Simulator. And they might have older hardware and really old hardware. And this seems to be a recurring thing for friends who maintain other open source projects, that open source users' barrier for how old hardware should run their software is much lower than, like, say, Windows or Mac. So people trying, on like 10-year-old laptops or even 12 or 15-year-old laptops that don't really have 3D acceleration and, just like full of stuff, like just grinding to death because it's Windows, they haven't reinstalled it in however many years. So computers are slow. Obviously not your computer. Your computer's fast, but everyone else's computer is weirdly slow in weird ways. And users are also very impatient because their computer's slow, but they don't really acknowledge that. They just want things to happen now. But this is another way of saying that UI can be terrible because, of course, if your UI explains what's happening, the user won't be so impatient. But that's how you want to define that problem. And again, they have archaic hardware. And so not just slow, but also kind of weird configurations and weird old stuff. Especially for 3D stuff, this basically means old Intel graphics chipsets, which should all be put in a dumpster and set on fire, but they're attached to people's motherboards and can't be. So, the other one that really surprised me when I started getting data coming in is file systems fail in all kinds of ways that make no sense, especially Windows, especially around paths that contain OneDrive, which obviously is how it puts your app data roaming up into OneDrive and then magically shares it. And if your software just thinks that app data roaming or whatever is just going to be some normal files, boy, if you're in for some surprises. So you get just like permission denied reading files. You get files that you wrote that come back as 0 bytes. It turns out that Windows has a blessed list of programs allowed to do things like extract many small files. And if you aren't on that, and that list obviously built into Windows and obviously contains things like p7.exe and zip.exe and a bunch of other utilities, including like the ones built inside Git, whatever, like zip and tar. But if you as a random program try to extract like a zip file, and we do, it'll go tremendously slowly, so it checks every single file one at a time in some kind of weird, well, it's not weird, it's a security feature. But again, there's no way to get on the blessed list. But it's not unreasonable to want to extract a zip. It's just that when we do it takes forever on Windows. It takes no time at all on Unix, but yeah. And then malloc actually does fail. I know you never check it and no one ever looks, but actually malloc can fail. Again, especially if you're loading lots of large images, user supplied, which might be, a quarter of a gigabyte single texture for the exterior of a plane or a building or something. So yeah, there's just an enormous set of weird things that can happen. And you can look at these and say, well, how does that make it crash? Well, that's what we're going to see. I think for time. Oh, not too bad. So we'll start with Impatience. I would say this one isn't really about performance, although, yeah, maybe. So Flight Gear, obviously being a highly advanced bit of software, for a long time loaded about 200 megabytes of ASCII text on each startup to parse it. There's like a list of every airport in the world and radio frequency and blah, blah, blah. That was really slow, and I got sort of watching it do this every time I started the program. So I built a database to essentially cache the data in SQLite in a binary form, which basically halved our startup time from like a minute to 30 seconds. But of course, the first time you run the program, it needs to build that database from those text files. So it's got to read loads and loads of files, do masses of annoying string parsing, and then chuck this all into SQLite using lots of SQL inserts. This takes about maybe a minute on my machine, but some people it takes longer, potentially much longer, because it's obviously doing disk reads and disk writes. So of course, people sit there and like, okay, we need a UI for this. I'm not an idiot. I mean, I might occasionally be an idiot, but I did actually think, yeah, we need a UI for this. So there's a dialog that pops up that says, we are initializing navigation data. This will take a few minutes. It has to be done. Please wait. I thought I could not make it any clearer, but and of course, we don't want to block the UI, so we use a worker thread for doing the actual rebuild. So code essentially as shown, we have our database rebuild task, and we start it, it goes away, starts reading files, parsing ASCII, doing some conversions, doing SQL inserts, doing it with transactions, blah, 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 blah. It's quite happy. In our UI, in our main thread, we create a progress dialog, which basically has a progress bar. We have some kind of update callback, so periodically it runs, says, is the rebuild thread done? And if it is, we close the dialog and we're fine. If it's not done, we update our progress bar to go along a little bit further. It's a percentage progress bar because I'm not stupid enough to try and do a time estimate because, of course, the times will be completely nonlinear. But as a progress bar, it's moving. You can see it progressing, possibly slowly if your machine is really slow. And then having done this phase, okay, we know the navigation data has been built. We've shown the dialog. Of course, this only happens the first time. If the database has been built, then this doesn't even run. Then we carry on with application startup. And probably the very first things we're going to start doing is using this database because it's got all the airports. We need to say, okay, where do you want to start? Do you want to start in Bristol or London or Paris? We need to know where they are and lots of other information. And then we immediately get a crash, sometimes, because the database is in some weird state. And it's like, what's going on here? And this is an example of iteration. I think this took me 4 releases of the software to actually fix. And each time I'd go and add a bit more logging and a bit more tracing, which would show up in the crash reports. Anyone want to guess how it might be crashing? Sometimes, for some users, round about here, trying to use a database. Good answer, disk is full, but no, disk is not full. Nope. It's better than that. So remember, the title is Impatience, so it is a user-driven problem. So what's actually happening, again, this is as always, the actual thing is like, oh, how could you ever have known that? That's annoying. Well, it is. So this progress dialog obviously does not have a cancel button. It's just a progress bar. You have to sit there and you can't cancel the program. And now some people will say, I should have a button labeled exit or cancel that then quits the program and then would restart it the next time. But I didn't do that. I was like, well, they want to run the flight simulator. They're going to wait the minute or two it takes to run the flight simulator. Apparently what people do is madly thrash the keyboard because they're looking at a progress bar they can't get rid of. And they try hitting Alt F4 and escape and some combination. And it turns out that even though you don't have a cancel button on Windows, by default, some of those keys will close your dialog. So basically, this will call close, but if the user, as it was configured, madly hits the keys, the dialog will close. The thread, of course, is not finished, so somewhere down here, the thread's still running, but then this tries to carry on, and boom. And it wasn't until I went and had logging in the rebuild task saying starting rebuild, progressing rebuild, rebuild is done, and then logging here saying showing the dialog, closing the dialog, oh, the dialog must have been closed now, then looked at me in the log and went, those are out of order. I mean, and once you understood it, you can go back and look at the very first crash report, and you can sort of see all happening, but it's that kind of detective work thing of understanding, because your brain's just like, it must have done that if it's got to here. Well, it hasn't. So yeah, and of course the fix is to basically go and mark this dialog with some special flag that says disable all key presses or something like that while it's running. More impatience. So we have a custom UI thing we run inside the application. It puts a menu bar in the window. I'm a macOS user, therefore I believe the menu bar should be where Steve Jobs intended, at the top of the screen. So I added some code to use a macOS native menu bar at the top of the not the window, the top of the screen. So that's where the system menu bar goes on Mac. Life is good. I was very happy because I had the menu bar where I wanted it to be. Everyone else carries on using the built-in menu bar. We initialize the GUI fairly in startup. We then show a splash screen which blocks while we do a whole bunch of loading. Depending on how complex the aircraft is, like if it's a little, piston-powered biplane, loads in like 10 seconds. If someone's modeled every single switch on an A380, which they have, it will take about 3 minutes to load all those switches and buttons and hydraulic systems and everything else in an airliner, because airliners are quite complicated. So we block during that, and then we get some crashes. And it turns out that, obviously, while the splashing is there, it blocks the menu bar, but it doesn't block the Mac native menu bar. And then someone starts using the menus while the splash screen is showing and firing off menu items like open this dialog or do that thing, and the code is not prepared for that, and boom. So of course the solution is to disable the menu bar while we're showing the splash screen. Even more impatience. This one could argue about timing as shown. So we have a startup launcher. Helps application get going. So basically says where do you want to fly, what time of day, what weather, whatever. So it's got some button which actually labeled fly, which says basically start the main stuff. It's got to do some preparation work, and then it closes its window. Fine. So we show that window, blah, 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 and we exec it. And then we carry on, and we actually do our real stuff. And what we got is some crashes because we're doing this twice. And it turns out the users will just click the button repeatedly. This might be older people who think they have to double-click everything. Because my dad does this. He got taught in 1990, whenever it was, to always double-click. And now he always double-clicks. So it might be a good test for your user experience testing to get someone who's old enough to basically double-click every button and see what your UI does. Because it turns out if the system's slow enough, and I can't reproduce it on mine, in between this saying close and this actually exec loop coming out, it might process the next click again, and you get back in here and do the prepare some stuff twice, which I wasn't expecting. So of course now I have a guard that says if we've already prepared some stuff, don't prepare it again. But yeah, and you're like, oh, surely it closes immediately after doing this. Well, it might, but it might not, depending on the computer. Ah, yes, malloc. Yeah, C++ throws bad alloc, which sounds like it should be something cooler than it is, like maybe the name of a band, when it can't allocate, say, a vector or whatever, one of its containers. And FlightGo, for its sins, does use exceptions, but exceptions it doesn't recognize tend to percolate up to the top and then essentially cause the program to crash. And user developers saying, well, it didn't technically crash, you just got an unhandled exception, doesn't help anybody at all, apart from making a user more annoyed, right? From the end user point of view, an unhandled exception or an exception handle right at the top and just says, bye, is no better than just crashing, really. In fact, I won't say it's worse, but it's certainly no better. So the thing that to figure out where these are coming from, the thing that really saved me here is this set new handler. Who's aware of that? Because I had to go and learn it. Cool. So yeah, if you're ever in this kind of situation, set new handler lets you replace global new and do something. So you're in the call stack at the point that, for example, the malloc fails. And at that point, so this is the next thing we're going to come on to, or in a slide or two. Once you have a crash reporting library, you also have a way to capture arbitrary backtraces in your program. So that means in set new handler, I can therefore go and grab the stack and see which allocation failed. And it turned out that 90-something% of them are the same allocation, which is our image loader, because that's basically where we load big amounts of data repeated readily. It isn't some 4-byte, pointer or some 8-byte string, whatever it might be. They're really all coming from one place, which is the image loader, because it's loading multi-megabyte or even up to, well, not quite a gigabyte, but a quarter of a gigabyte sized image files. And that's obviously where it runs out of memory because they're big. But even if that information was completely invisible, prior to doing this, the user perception was, oh, I try and load this aircraft, and at some point through, it just crashes. And of course, actually, it's just running out of memory because it's filled it all up with big pictures. So I'll come a little bit more into error reporting and kind of non-crash things, but this is a crash becoming an error, which is actually a very good transformation. One more example of slowness. Network check for, is there a new version? Just a simple check of web server. Reports back to our GUI saying, oh, there's an update available, please click to install it. Nothing very fancy there. We have ref counting on the requests, so once they're done, they're cleaned up. Life is good. Turns out, because it involves a network, and again, this is obvious with hindsight, but some people, you make a network request, it just takes forever to come back. And even it doesn't even fail quickly, it just fails after 60 seconds or whatever. Or it even doesn't succeed, but it returns you some data, like a weird response code from their proxy or their ISP's, we blocked this, or something weird like that, after a long time. And of course, I hadn't allowed for this because it normally takes a few seconds even to fail. So if the startup GUI, which it calls back to, is gone, it would then crash. That one was quite easy to discover, actually. But again, it's that thing of, have you thought through all the ways that, slowness can mean for your program? And networking ones, maybe I should have realized it, that, it can time out after that long. And of course, we did have a timeout handler, but then what we actually need to do is add cancellation. So it basically requires us to cancel all the requests when the startup GUI is shut down, because at that point, there's no point responding to them anyway. It's quite depressing so far. Now we get to the really bad bit, drivers. This I mean OpenGL drivers, by the way. Other drivers are fine. Well, they haven't annoyed me so far, but OpenGL drivers are a problem. Because there's so many versions, and users tend not to update them, and then some people update them very aggressively, like if they've got the NVIDIA GeForce thing installed. And we have some minimum requirements about, we have to have certain features, otherwise we can't do certain things. That's all right. We can just check the OpenGL version. We'll create our window. You can query what version you got, and we'll give the user some clear feedback saying, oh, you've only got 3.0, we need 3.2, that's fine. So yeah, we'll do that check when we create the window, fine. Good, nope, crashes, because the call wasn't done the right way. It's like, okay, well, what we'll do then, we will make an off-screen window before we even start the main window up with much simpler things, and then we'll query on that. And then we'll check which version we got back. And that still crashes on some Intel drivers, because of course it does. Like the simplest kind of example you can make of WGL create context and make it current, and then call GL query version, whatever. So then you go and start doing some rearranging, and you kind of make sure you do a done current before you do this and something else, and you get rid of some more crashes. But in the end, I still can't fix them all. It just basically, there's some Intel drivers where if you even glance at the OpenGL and even sort of maybe look at it the wrong way, it just crashes. Now, crucially, these are the really archaic ones where what you really want to do is tell the user, you can't run the software. All I want to do is say, your machine's too old, this isn't going to happen, just buy a new laptop or move on to a different bit of software. But even to give that feedback, they have to know what driver they're running. I guess I could start doing things like doing a star.dll on system Windows for the file name, and then probably query out the version as a property, but this is meant to be fun in my spare time, so yeah, I don't know. By the way, all the other drivers crash as well, just less commonly. So you'll periodically see a version of the NVIDIA driver or the ATI driver in some range of versions crashing as well in the middle of nowhere. But those are kind of, on occasion you can even see which call it is or some version. It's not just Intel, but Intel is 20 times worse than all the others. So this is all the bad news. The thing is that there wasn't actually that many crashes, possibly affecting the size of the user base. So then I got overconfident, which, as we're all aware from Star Wars, is your weakness. I was getting sort of, 4 or 5 crashes a day. Yeah, it's manageable. So how about on non-crashing failures? We have an exception class, like a base class. It actually inherits standard exception, but then all our exceptions inherit from our own base class. As I said, if we have a crash reporting library, you have a stack trace snapshotting library at your disposal. And also, if you have something like Sentry, you essentially have a problem collecting backend at your disposal. So yeah, so I did catching all the exceptions which are created in our program. Whoops. Came back a couple of days later, opened the log system. Yeah, it turns out that if you have user-supplied content and everything else that we have in the program, you have a lot of failures. And this is where the things like the file system stuff started to really show up and parse errors and download the content. I mean, the crashes, it turns out, are the easy bit because they definitely stop the program at a certain point. It's the kind of pre-train wreck of bad data and bad stuff happening. And again, this is particularly bad for flight gear because it has user-identified content. If you have a lockdown application, it's going to be a lot better. But it also comes down to things like, I've got a friend who works on an audio editor, and it's things like, oh, you definitely can't get a WAV file that doesn't have one of these codes or this stereo layout. Well, you can. And you're definitely only going to find, this file format thing. Well, you're not. It just turns out in the real world, if you load any kind of data, you'd get this, and it's maybe not numerically that big, but the spectrum of ways that things handed to your program can change is just probably bigger than you think it is. So what are we actually covering here? Well, downloaded files. Some people just author broken XML because they can't write XML, or they used something that inserts the wrong kind of control characters. Used Word to edit the file, and it put curly quotes rather than straight quotes, which doesn't parse. Lot of things like firewalls and proxies replacing all content with the same 404 error message HTML rather than your actual content. And then also just things appearing as 0 bytes for no apparent reason. Again, this seems to be especially a Windows thing of sometimes it's actually permission error, sometimes it's actually the file is 0 bytes for no apparent reason. Then, of course, there's just the usual, the UI let the user misconfigure it. Fine, okay. Then we have completely gross configuration errors where people have just gone in because they found something on a forum saying, oh, you can double your performance by changing this number to be a different value. And they just go in again and just more or less do a drive-by destruction of their configuration data. And then we have all the ways OpenGL can fail, surface formats missing, texture formats not supported, maximum size is out of range. Quite a few of those do crash, though, so hey. So I'll go through a few of these, but this is, again, just me helping to, process all the ways I've repeatedly smashed my head into the brick wall since I added the systems in. It's getting better now, and we'll look at some actual positive conclusions to this before you all kind of leave here thinking, I probably do need help, but not because of this anymore, hopefully. But there is some kind of positive outcomes, but not yet. Don't worry, this is still the bad stuff. People download aircraft. They're made by, say, enthusiastic contributors. A team or a person will make an aircraft, which is basically a collection of data files. There'll be some XML, there'll be some 3D models, there'll be some sounds, there'll be some scripts, there'll be some numerical data that defines how it flies. That's all usually in a zip. And inside that, there's some kind of master files that configure it all, some manifesty things that have relative paths, and they're referenced to the name of the aircraft, which is the directory name. A lot of people do their aircraft on GitHub, and you can download a snapshot, as I think either a zip or a TAR-GZ, of a current state of a branch. And it sets an automatic directory name, which is based on the branch and is definitely not just the name of the repo. Therefore, if you just drop this zip file and extract it into your search locations, it won't work because the name is wrong. And it shows up in a really weird way. Basically, we get an all files are not found. So of course we have a download page that says, you must rename the directory. And we have a README that says, you must rename the directory, and so on and so on. And we do now have some UI that says, you need to rename the directory. But an amazing number of people just obviously extract the zip and plonk it somewhere. And so one solution is add some UI and add a check, because you can check for this. All of this entire system shouldn't even be needed, because we have an automatic way, a bit like a store, to go and install aircraft using a button UI that unpacks it for you. But that's also why we have the zip extraction being slow, because we try and help the user and unpack the zips for them and put them in the right place and not screw up the file names and all that kind of thing. But of course, they want to get the bleeding edge version from Git. So then they ignore that system, which would help them, and then go and download the zip manually, and then ignore the READMEs for that system, and then the system doesn't work because the files aren't found. I think, again, because it's free, people are really enthusiastic, but they're really impatient. Just if you just read a tiny bit more and just, it would make sense, but no. And again, age demographics and things might all be factors here, but you always think you can user interface your way out of these problems, and you can try and you can try and you can push the percentages sort of along the problem curve, but you can never actually wipe it out, because there's always going to be someone just happily clicks through, and Windows will extract the folder for them, just drag it from the thing that pops up Windows into the folder they want, and then it doesn't work. The next one, though, was actually me, rather than a user issue. That's good. So it's actually my straightforward stupidity, coupled with some user ones. So SQLite, we have that for that cache thing I was talking about, and it allows multiple processors to access the database. Why does that matter? Well, we let users run the software multiple times. And we have a usual other problem here, that being a bit of a toolbox rather than a single program, users want to run the software every way they want. Again, this is, I would say, an open source thing, that users just basically, well, it's open source, I can use it however I want. That's true. So that means we have to support multiple launchers, because people are doing things like tow planes and air-to-air refueling and trying to land on a carrier where, they're doing one thing scripted and another thing they're actually flying, and lots of combinations like that. So they can therefore launch multiple copies, and that's a feature. But then lots of users launch multiple copies unintentionally because they're impatient and the computers are slow and the window hasn't appeared. And again, on every machine I can try, we show a window within less than a second. We're not especially slow to show some kind of feedback that the program is running, but we still get a lot of multiple launches. And we show some UI that says, okay, this is a second launch, we're going to run read-only here, because we basically, to try and avoid having problems, we just say, okay, all the secondary copies run read-only on the cache data. You could get even more clever, but I don't want to. And a feature of SQLite is if you've got multiple processors, any API call can return busy to say, actually, when you tried to do this operation, another process was touching the database, and therefore you need to retry. That's okay. I knew about this, and I wrote a little loop, a retry loop around our exec function. And basically, when it gets busy, it just retries the query. Maybe a millisecond later, it sleeps, and then it backs off like 1 millisecond, 2 milliseconds, 4, 8, up to some maximum. And if it's backed off to like a 45 millisecond wait or whatever it is, it says this is crazy, we're broken, and carries on. And that should be fine, right? But say now we're logging errors. So one of the errors I was logging is, well, do we actually hit this? And it turns out we do. We still get occasional busy errors because I'd forgotten that as well as execing the queries, you also have to prepare them. And it turns out the query prepare can also fail. I mean, it's only on start, right? We're only just preparing 30 or 40 SQL queries. But of course, out in the real world, people doing multiple launches, that happens enough to show up in the software. I mean, to reproduce that in testing, I'm not saying it's impossible, but you'd have to just get so lucky to spot it. The minute you give it out to the world, the things that never happen often enough that it even shows up. So yeah, that one was a straight my fault of not realizing that every single API call could fail the same way as the obvious one, which is the exec. Okay, we're nearly done with the catalog of horror. This is the last one. Yeah, old paths. So we have a list of search directories, a bit like your path variable, or LD library path. And you can add them from a file picker. So this is like where we're going to look for add-on scenery or add-on, simulation files, whatever it might be, list of paths to search. And we persist that because we're nice people. Back in the old days, you had to specify it every time in some environment variable. We actually, persist it. We have a GUI for it. That's fine. And we validate the paths on load. Nothing surprising here at all. So then we have a GUI to modify this. And I thought I was being very clever. We initialize from list of paths, and we skip ones which are missing on the system. It turns out this means we persist invalid paths forever internally, because of course, when they become invalid, so this is basically people doing like a path to a folder, then renaming it, or a external drive like a NAS, and unplugging it, and all those combinations. And then we start getting error reports where people have got like 30 invalid paths with the same word misspelled, but 8 different times because they've renamed the folder until they got the name they wanted. And each time it had been added, and then it didn't work. So they rename it again, and it didn't work until they get the right name. And then all those wrong ones are then hanging around invisibly. So it's a thing of like, well, actually the GUI needs to show you the invalid paths so the user can delete them. Again, it's a UI design failure, but you'd never realize it because as a developer, you never go and add like all these invalid paths. It's just not a thing. Even a tester, I guess a tester might do that if they're a good tester, but users will find more creative ways to enter bad data than I think any tester ever would. So yeah, so this was effectively just us persisting bad data forever because we'd taken away the option to delete it. And then you see the report and you're like, there's a lot of bad paths in there. And it's like, oh, okay, because they're there forever. Okay. Some conclusions, though, some actual positives from this. Start thinking more upbeat. And by the way, this is where I cut off my list. I could make this presentation twice as long by just keeping going through. What I was doing for a while was, especially during lockdown, each evening when I ran out of coding energy, I would just take the top current item off the, how many users or events were happening. I'll show the UI. And just basically try and understand that crash or that error this evening and spend maybe 20 minutes just looking at it and being like, okay, what they have in common, what don't they have in common? And then basically the next day I do a different one and so forth. And it's that thing of like trying to solve like a riddle or something. You kind of need to pick it up and turn it around in your hands and read it and then look at it. and then maybe you think, oh, I can add a bit more information in, and then you kind of put that one away and then come back to it in a few weeks' time when you've got a few more crashes or reports have come in. And for a while, my girlfriend thought I was getting really quite, like, depressed. Not quite depressed, but, like, fixated on, like, just being on this, being like, what are you doing? I'm just trying to work out why this person is just having this, like, how can it possibly be breaking this way? And then you do the next one. And every time when you fix one, you get that elation of, like, I finally understood how it got into this state and fixed it. But then you go back to the next day to, like, I've no idea why. So, like, just chipping away at it, it's been quite fun, but this is why this is therapy for me, to just put the worst ones or some of the fun ones on the screen and go through them. The big one has been trend analysis in terms of, well, one of the big ones, that how things evolve is really valuable. So it doesn't help for flight gear because all the bugs are historic. But as soon as you start introducing new bugs, I mean, you're never going to do that. You're all too smart for that. But if someone introduces a new bug, you'll get the first version it happens in. And that's really, because then you can start actually using git bisect and that kind of stuff to actually zero in that kind of way rather than having to work out from the occurrences what's going wrong. So that's really good. But also the correlation of the metadata I was talking about is really valuable in just saying, okay, because it's only happening, example of flight gear, in 3 kinds of aircraft and not the other ones. We know it's probably an aircraft bug. It's happening in all the aircraft, but only in certain places or a certain platform again. So there's an awful lot of correlation that will help you to start to think about, well, because you need that kind of sort of stepping back and not just getting too focused on the detail of the crash, but also what's the context, what were they doing before, to try and just have that inspiration of, oh, it's doing this. Updating new versions is really interesting because, again, as you do fixes, you can sort of see how problems drop down occurring frequently and then how other problems become more visible. Yeah, it's very much whack-a-mole that you fix the current worst one, and you do a new release, and then another one has become the worst one, but hopefully numerically fewer and so on and so on. But there is a bit of a, that one, okay, now this one, now this one. The other interesting thing you get is you get session duration and you get the percentage of failed sessions. And that's a really depressing number, again, initially for me, which is basically for every people who start the software, how many of them have a successful outcome, they did what they wanted, versus that ending in a crash or an error, which is probably not what they wanted when they started up the software. And that metric of what percent of your users' experiences or your sessions are ending poorly. Again, Flight Gear is open source. I'm just doing this for fun, but obviously commercially, that could be a really important number in terms of actual. And again, this is all hard data. This isn't supposition or theory or user polling. This is like concrete data about how users are using the software. And this rapidly skews into analytics, which I've deliberately not pushed very hard because obviously you can also just go and build Google Analytics in your program, but into things like time spent on screens, time spent on the loading screen, time spent the user kind of clicking help buttons on dialogues. You could actually go down a whole analytical rabbit hole here, and I absolutely haven't because I haven't got the time for it. But obviously you can start analyzing things like uptake and retention and say session time if you want to. And say something that you more or less just get for free. If you're doing any kind of tracing of your program, you get this more or less, it just falls out. But how far you want to go with it, very much up to you. But the other big thing, especially about the error reporting, is about surfacing stuff to the UI. Because, again, open source code, the normal error handling is if function fails, either throw an exception or return, which I guess is normal error handling for lazy people. And we all know that's not error handling, right? We should do something much more intelligent, whatever. But we also know that if we did all the error handling we should do, we might never ship our software. I mean, again, you can argue about this, but it doesn't make sense to do all the error handling in the world for all the errors that could possibly happen. So the really good thing here is it lets you direct where it might actually be worth doing better error handling. And so one of the consequences of all of this is I've spent the last year adding a proper error reporting UI into Flight Gear. And this is a really hard thing to do well because you're trying to surface errors to the user, and obviously errors when they usually occur are technical and very specific, but also specific to something that the user doesn't really understand, like a checksum has failed or a malloc has failed or a file isn't writable. And so you need to surface that in a way that's understandable, but also actionable. Otherwise, it's just frustrating noise. Like, just the abort, retry, ignore because code 5397 has happened. Well, that's also not understandable, but it's also not actionable at all. And also, as I discovered after I deployed it, it has to be a very non-annoying UI, and people's ideas of what's annoying and not seem to vary quite a lot. But for example, the memory allocation errors are largely caused by aircraft having too large files. Basically, aircraft authors want their aircraft to be very pretty, so they tend to use maybe a 4K by 4K texture, which I think is 64 megabytes of memory, or nowadays they can do an 8K by 8K texture, which is 256. And of course, some of them want to do a 16K by 16K texture. That's an image 16,000 pixels square, which is a ton of memory, but it means you can basically have every speck of rust on a 747, which apparently some aircraft developers really want to do. Because it does look beautiful on your Spitfire or your whatever, to have every little dimple in the canvas. You can't actually see any of this, by the way, because you don't normally put your nose this far from an airplane, even in a flight simulator. But the kind of people who make aircraft for flight simulators in their spare time do think this is a good idea. But prior to surfacing the errors, when that aircraft crashes, because the malloc failed, that's just flight gear being broken. And the thing the UI does is say, oh, this crash loading texture files from your aircraft. So basically, it's an aircraft problem. You need to go and either ask the aircraft author to change what they produce, or make a lower quality version for your older machine, or just, so it's trying to close the feedback loop and also ideally take me out of it. If I'm to be the guy who tells the aircraft authors, oh, lots of these aircraft have textures which are too big, which is what historically happened. So giving the users a thing that says it's a lack of memory, that's when they can action. They can either buy some memory or change the aircraft they're flying, or saying the file system is screwed up and it's not readable. Again, that one actually isn't that actionable because depends. But okay, if I detect a string that says OneDrive in the file path, I might then do a different thing that says, maybe don't put this on your OneDrive, maybe put it somewhere else. It's those kind of things of really understanding what you could surface and show that would actually make a difference. And again, this is all backed by numbers. You can see how many reports you're getting per day of this error happening or this crash happening. And again, that also comes down to if you've got hard data to work with, it's much easier to go and tell people, okay, like this is worth spending time on, or this isn't worth spending time on. Like, so I've been able to go to a bunch of people and say, look, we might need to work on like a texture downscaler that if you're running on an older computer, just resizes all images to a smaller size before we load them. That's a thing we could do. It would be a pain to make. We have to go and do some kind of rewriting and all the checksums would break. But if there's enough people out there, or we just tell people we're not going to do that, you need to go and buy a faster computer, which suits me, but again, wouldn't make us very popular. Yeah, so I think that it's really hard to think about where it's worth doing this kind of stuff without having the data to work with. It really transformed my understanding of what was going to be an effective use of time, given, again, this is my hobby for me, in terms of things you could show versus just not worrying about. Because, again, the errors you think are going to happen probably aren't the ones that really happen. Do need to mention privacy here, because this is obviously a thing in your program that talks to the internet. I really didn't want to record any personal data. So you can choose to go down the we are GPDR compliant route, but I'm not an organization, don't want to have a GPDR compliance officer because it would be me, and again, hobby, spare time, not fun. So therefore, I've deliberately gone, and actually Sentry helped with this to basically say, I don't want to record, for example, IP addresses. And it means to identify users. So if you were doing something like a web service, they would let you use like the username, like whatever your login was, as a unique ID for the user. But I don't have that and don't want to do it. So I'm just generating a UUID on startup, which obviously isn't traceable or relatable to the user on first run, because you do want clustering by user. Like knowing that you've got 1,000 reports, but they're all from one guy whose setup is totally broken is quite valuable data. But a UID satisfies that without having any GPDR issue. So I was discussing this whole thing with someone, and someone was like, oh, just use their IP address. If you don't think IP addresses are personal data, you need to go do a lot of reading. Yeah, and Sentry helps again. When you record like a log or thing, if it sees a path that looks like a username path or a file path, it strips it down to a series of asterisks automatically, and again, doesn't record stuff. And if you want to go down, if you already have GPDR compliance, you go the other way and actually record all the stuff, and you get GeoIP and everything, but I didn't want to go there. And then also I had to add some actual new UI to consent the crash reporter, because again, you have to tell people we're doing this. It's an interesting point that I have no idea what the opt-out rate is, because of course those users who opt out are completely invisible to me. But again, I guess I have no idea if half the users opt out. I think it's probably more like 1% or something, but you have to give some kind of first run consent. The libraries will help you do this, because again, you can't just turn the system on and forget about it. You have to give people a way to turn it off. Right. I said I wouldn't talk too much about Sentry, but there's one area that comes up repeatedly, Sentry native, unlike some other backends, can't do user input on crash submission. That means showing up a little happy box when it crashes, which a lot of things do, like Unity and some of the Microsoft products, and I think Chrome does as well, where you can go and type in into a text box what you were doing when it blew up. And I think it's very questionable what this would add in terms of what I see in bug reports and things. I think you'd get a lot of emotion, and you might not get much information. I think that's the charitable way to put it, right? Yeah, it would be nice to do, but it means adding in, so the helper processes are typically quite simple and non-user facing. To show a dialog box means basically you have to either use native UI or include a portable UI inside the handler and things. And I filed a question about it with Sentry, and everyone was like, we kind of want it, but we don't really want to open that can of worms, so we're kind of leaving it for now, which I totally understand. And the other one is because it's visual, capturing the last rendered frame would be great, especially to see what was on the user's screen, except that, again, if you sort of vocalize you can essentially screenshot random people on the internet desktops and then send it to me on a web server, and you just sort of think, there's probably some ways that can go wrong pretty quickly. So again, I haven't even gone down that path. It would help with diagnosing some issues, but I don't really want to wade through lots of random people's screenshots and also you have to do a lot more stuff because you're going to need to read the memory of the process to get a screenshot out and all these kind of things, and there's more chance of it itself going wrong. So those are the kind of two things that people have been like, oh, we could do this. I'm like, yeah, I think I'd rather go with the hard data, which is the crash reports and the logging, and not try and do user input and the frame grab. One thing one thing I haven't maybe covered here is that I did this with Flight Gear partly to learn it, because at my work we offered the solution to other customers or suggested it, and it was basically a way for me to learn what crash reporting could do and what data it would give. And in a commercial situation, a lot of what I just said about user things could be different. If you've got a beta tester pool and you can go and enable a flag, and those beta testers are consented to, for example, have screenshots made or run different versions, there's all kind of things you could do here, because you could basically have the build be a bit smarter. But again, that depends what relationship you have. If you have a contractual arrangement with your users or a subset of them who, again, you can consent specially to run things that gather more information, go nuts with it. Or even just running it on a test farm, something that's in the building but in the basement overnight. Again, this still has lots of value because, again, the odds you want someone stood there at midnight for when it crashes is very low. So any automated collection, even of that scale, might be a huge win. It doesn't have to be this worst case of out in the bad wild world with just Joe random on his random computer. So lessons learned. Intuition is usually wrong about errors and crashes. Usual thing there. Like I say, I thought it was going to be lots of pointer errors. It's not. It's just the amount of ways the data can be screwed up, especially, and then Opengl drivers. Don't wait to do this. That's the thing. Like I should have done this 10 years ago or whatever it was, 8 years ago when it was possible, and then incrementally got it better. Like if you don't know what to do something and measure it as the joke and or the rule, and it's true. So I think it's one of the things you can imagine lots of perfect solutions, but doing anything will start to close the feedback loop and then get things working better. And again, the feedback loop's important here. Most of the hard bugs I've not fixed in a single version, or I fixed them by adding some logging and then doing a release, and then adding some logging into release. And the faster release cycle here really helps. So I think prior to adding the system, we were averaging we would do maybe 2 or 3 point releases of a stable version and then move on to the next one. And now I'm on to the 14th or 15th point release of our stable version, because you find 4 or 5 bugs and you want to get a release out that fixes those 4 or 5 crashes and then get some feedback. And probably incidentally, you fix five bugs and you add some tracing in for the next 5 you're kind of working on that don't currently make sense. And so you kind of want to get at that and see what happens to those numbers. So it really does help if you've got the kind of, push a release out every few weeks, every month, whatever thing. If you were only pushing a release out every year, I'm not saying this wouldn't work, but I think it'd be harder to kind of join the dots. Again, if you had a beta testing pool, would probably satisfy the same thing. But I think you do need to be able to, again, I'm not going to apply any particular development methodology branding around this, just that the faster iteration tends to be more motivational in terms of looking at these kind of problems. Okay, that's the end of all I had to say. I will throw this open to you to either share your own stories. If anyone wants to come up here, I'll say if you do want to come on stage and have a cry about the worst crash you've encountered, that's fine. If you've got questions about what I did, feel free. I haven't actually shown Sentry, so I'll just switch to that while we do the Q&A to give you an idea what it looks like, if I can. It looks a lot like a Jira type thing. It's just basically, oh, where's my mouse gone? It's basically a scrolling list of what comes in and particularly how many events and how many users in a time period. And some of them will just have one user and you can ignore them quite happily. And some of them will have, actually, I'll go and, is it sorted by? Yeah, let's sort it by events. And yeah, so this is, I'm not sure what period I'm on here. I'm probably zoomed in too far. But yeah, we can go and, oh, I've done some weird zooming thing. Okay. Yeah, and we can go and just start seeing, okay, which ones is actually worth looking at. By the way, the ones that are saying error category, this is me grouping and clustering types of errors in the new error reporting system. So these actually are me working out how often is this really going to, does this kind of error happen? So I've lumped all the ones in this category TerraSync under one heading in terms of the aggregation that Sentry does, because that's easy to track. Okay, it's happening for, so you can see again straight away, okay, there's lots of people getting 2 errors per user. Well, that's not great, but it's not the end of the world. But there might be some here, probably not. So yeah, okay, here we go. Whatever's going on here, there's 31 errors, but it's only happening for one person. Unfortunately, that does make me less interested in fixing that issue, whatever it might be. You can also see it's some out-of-range index, which, for whatever reason, probably, this might be a good example, there's probably one aircraft that uses too many canvases. If I go and look at the tags, yeah, it's very likely that the MD11 is broken in some particular way. So I could go and annoy the MD11 maintainer if there is one and be like, hey, you might have a glitch in your script code there. Because this is a very particular list of aircraft. It's not all the aircraft we have. It's clearly the A320 and its variants. And then the A330 is done by the same guy as the A320. So again, it's probably something in his code. And actually, he might have done he did the MD11 as well. Right, I know the guy. Based on this list and knowing who maintains those aircraft, I know it's going to be one guy who's got too many canvases probably. But again, it's only happening for one user, so maybe a life's too short. But this is kind of what I mean about the digging into the detective work and seeing, well, is it worth worrying about this one? Is it not? Yeah, who knows? And then you change the data and you move on a bit further. Yeah. The floor is open. Oh, if you wish. Does anyone want a microphone? Or just shout? Is it on? There you go.
I would like to know, with this tool, how do you clean up because you start having a lot of exceptions that is going on, and after that, when you fix something, you have to clean it.
So for any issue, you can go and mark it as fixed in a release. If you've actually fixed it, so you can go and do a resolve and say resolve in next release, whatever that might be, because this knows about your release versions. That's one of the things it tracks, is when you define a new major release version, you basically go in and file it and say, here's the binary for it. It's also got some really nice features, which are this ignore, which is basically ignore for some time or until it occurs a bit more or until it affects more people. So if it's happening for one user, I'll basically say, don't worry about it until it affects 10 users. That's a really nice filter. The other thing that Sentry does, again, this is tunable, is if a report's basically had no activity in, I think, a month or maybe 3 months, it just closes it, because otherwise you just have an endless backlog of things that are never going to happen again. So this is where, again, I know Sentry now from using it quite a bit. I'm not obviously going to say that all the other competing systems have similar, but I think they all do, to basically let you manage the amount of data. Yeah. Any more?
Hi. Firstly, that one user, you don't suppose it's the maintainer of the A320, do you?
Oh, very possibly. That's the annoying thing about having out all the anonymous data. I can't correlate who it might be, but it's a good question. So actually, one thing here, so we have a developer mode on the software, which we meant to set if you're doing development, like aircraft development, and that turns off the error reporting, so I don't get lots of backscatter noise from people actually working on the scripts. And probably I need to be stricter about that, because no one really cared about that flag, even though they should have been using it all along. But yeah, that would hopefully reduce the amount of noise that occurs from people working on the software.
Yeah, also, what kind of automated testing regime do you have?
Well, Obviously,
project?
being a legacy code base, it had zero automated testing. I'm working on that as well. So we now have a bit of test coverage. If you had perfect automated test coverage, I think you'd, not saying you wouldn't need this kind of system, but you'd have a different experience with it, right? Because it would push the software a lot more. Ideally, every time I find an issue here, I would add a test case that covers that situation. Right. Yeah. It's again, for the kind of the easy crashes, that's usually easy. The bigger question is like, is it even testable? So some of them, because it's external data. So there's been quite a lot of like, yeah, if this file read returns 0 bytes, or if this file read returns an e-permission or e-perm type failure, dealing with that. And you can do a lot of testing for that in places. It's amazingly imperfect. I mean, there's good examples where it works really nicely. So there's one, if I can go and search, where's the search box gone? Let's try. A METAR is the aviation name for a weather report. Right, here we go. So METAR reports are small ASCII strings that come in from every airport in the world that has a certain level of advancement, not just an empty bit of grass in the middle of nowhere, but if it's got like, a weather station, basically. And they're short strings with a well-defined format that says things like, is it cloudy, is it raining, how cold is it, which way is the wind coming from? And so we get one of these whenever the METAR string we got back for a given airport was not parsable by our parser. This is a given because basically I did quite a few, but there's essentially an endless list of just on some random day, we're going to do the tags, let's go and do the events actually, what's failed recently. And this is a good example of where you can, because we used to get reports of this. Oh, come on. So actually here the aircraft is unveiled. Let's go and crack this one open. And down here, so actually the stat trace here is rather irrelevant because we know where it comes from. Hopefully the last line should be, right. So you can basically attach some arbitrary key value data. So this is the actual data that failed. So I can see here the airport as this WABB. No idea what that is, I have to go and look up the database. But essentially, for whatever reason, this string is invalid in our parser. So one thing I can go and do is just basically, every time I get a failure here, just go and add that to our test data and then fix the parser handler. I don't even know what in here is illegal. It looks about right. That's approximately the format, right? But of course, occasionally one of the robots that produces these somewhere in the middle of nowhere puts in a weird string and our parser doesn't handle it. We need to go and improve our parser. So you could do a lot more automation around here. Again, Sentry's got a full API. You could go and start querying the stuff and pulling things out automatically. I haven't got that far. I have to go and manually go and extend our tests based on this data. But it can give you a really rich source of things to drive your automatic testing. Sure.
Because you mentioned it's like whack-a-mole for you.
Oh yeah, completely.
And I just wonder if you start adding regression tests, less stuff keeps coming back.
I mean, eventually that would be true. Again, Flight gives a really big, really crusty code base. So I think that's absolutely true in principle. But certainly, for me, on this project, it's going to be quite a way before that visibly improves. Although, again, there is some good metrics in here. And is it in releases? Now, I had to do a change because something else broke. Unfortunately, it's not very clear here. But one of the things I should be able to display is, probably not. So there's this crash-free rate, and I've managed to get that up. So when we first released 2020.3, it was hovering around 89%. I've now managed to creep it up to like 92, 93, 94. Now, I don't think I've actually improved it as much as that makes out because I've just done a new release and had to reset some things. But it tends to stabilize now around, let's say, 94, 95% crash-free, which is still terrible. That still means 1 in 20 sessions and in a crash, which is really bad. But compared to what it was, it's an improvement. So, yeah.
Thanks.
Any more questions?
Just wondering, it's sort of related to privacy. Have you considered how these sort of experiences that you hadn't learned from would translate to an industrial setting where you have to worry about security and things like that?
The quick answer is I haven't much. I was talking to some people at a company just along from here who make a CNC robot, like an industrial cutting robot. And they have the same thing of like enthusiastic user base of people who are also kind of makers and therefore take things apart without even being told to. Like when the software locks up, they basically got the screwdriver out before they've even sent a crash report, which can be a problem. And So there's a whole thing of like, if it's industrial, do you even want it online at all? So the one thing Sentry can't do is offline collection. Some of the libraries can basically just write the data file to a location on the file system, and you could go and tell people when they're ready to put in a USB drive, extract all the crashes and mud up. That's doable. I haven't tried that with Sentry because it's more focused on kind of the online reporting for end user applications. But I say if you want to pick apart, so the actual client side bit of Sentry is really just a very thin wrapper over CrashPad and BreakPad. And those absolutely can do that kind of packaging up. I'm not sure if any features would particularly break on Sentry. They probably would, but you could fix them. But yeah, there's lots of things that I think what I would say there is working out what makes sense for the domain. And say for industrial, I think you definitely plug a USB drive in and download all the crashes. Because that's a very self-consenting operation. Of the point someone does that and sends it to you, they presumably know they're going to get whatever data is in those zip files right. So it's kind of safe or approved implicitly by doing that. Yeah.
Thanks.
No worries. Oh.
Hi. I've been trying something similar on my project. We use Backtrace, but I think it's kind of similar.
Yeah, they're all the same. Like there's Backtrace and there's AppVeyor and another one, and yeah.
Have you found any way to connect that to an external bug tracker? Because obviously we have Jira internally, and sorting out the million crash reports is just like I would like some automated filter. I would say just open a Jira if it comes up often again.
So Sentry is really good for this. Unfortunately, FlightGear isn't. So Sentry has lots of integrations for GitHub and GitLab and all sorts of things, which is why if I pick a random, let's try one here, get an actual crash. This might do it. We'll see. Although it might have a nonsense backtrace. Yeah. So will it work? No, I need it's broken on Mac. Let's try a Windows E1. We'll try. Of course, that one's got a not. So yeah, you still backtraces aren't perfect now. Well, that won't. Okay. Basically, it's got some integration with the Git repository we're using, and it will actually show you the code. And if you were doing, if you could tell it which commits were in a release, it could actually then start to do some automatic zeroing in. And if you were using Jira, you could do the same thing. You can basically link an issue to your somewhere up here. Again, it probably won't be enabled for me if I go and dive into an issue. You could basically go and link this to an external tracker and basically say when there's a commit to that GitHub issue, it would close that GitLab issue, and it would then close this corresponding one because they can be linked using some IDs. For FlightGear, we unfortunately use SourceForge for political reasons, and there's no SourceForge integration at all. It's all just non-existent. So unfortunately, I don't get to use any of that stuff because SourceForge is kind of weird and kooky, but that's how that goes. But yeah, in principle, they've got an amazing range of... I probably can't even show here, but if you go into, I think, integrations in here, they've got integration for nearly everything you can imagine, and they all seem to work. So I'm using the GitLab one. I'm basically cloning our repos from SourceForge to GitLab, and then that's how I can get, say, code visibility here. Them should just work. Let's try. Oh, yeah, so if I just go and click on one of these, it shows me the actual code that happened at. And again, if it was a particular version or patch, it will be doing more here. But again, this one doesn't know about our commits because I can't set up that link, which is really annoying. But in principle, it can do it, which is a pretty great feature. Yeah. Cool. This is pretty much perfect for time. Last chance. Going. Cool. Thank you.